Hi, first of all, let's read the problem. A pharmaceutical manufacturer wants to investigate the bioactivity of a new drug. A completely randomized single-factor experiment was conducted with 3 dosage levels, and the following results were obtained. There were 3 different grams in dosage: 20 grams, 30 grams, and 40 grams. And there were 4 observations for each of the grams. For 20 grams, the observations were 24, 28, 37, and 30. For 30 grams, the observations were 37, 44, 31, and 35. And for 40 grams, the observations were 42, 47, 52, and 38. Now, we are asked to do 3 different tests. First of all, letter A. Is there evidence to indicate that the dosage level affects bioactivity? Use alpha 0.005. Letter B. If it's appropriate to do so, make comparisons between the pairs of means. What conclusions can you draw? And letter C. Analyze the residuals from the experiment and comment on model adequacy. Now, using Excel, we put all the data in a new table. Then the next step is to get yi dot. That means the sum of all the lines. For example, for 20 grams we sum 24, 28, 37, and 30, and the yi dot is 199. And this was done for the 3 of the lines. Then we get a new data, which is yi double dot. That is the sum of yi dot. That means the sum of 190, 19, 113, and 179. Then we get a new data. This will help us to get the residuals a little moment. Yi dot average. That means the average for every line. That means that for 20 grams we sum 24 plus 28 plus 37 plus 30 divided by 4, and that gets us 29.75. And this was done for the rest of the lines. Then we start doing ANOVA, but first of all we have to get 3 letters. A, which is the number of doses, which are 3, then N, the number of observations, and then N big, which is the A times N, which is 3 times 4, gives us 12. Then we start making the NOVA, sum of squares. We get the sum of squares of dosage, which is the sum of squares of y dot divided by N minus yi double dot square divided by 12. Then we get sum of squares of total, which is the sum of squares of all the data, minus yi dot square divided by 12, which is big N. Then we get the sum of squares of error, which is the sum of squares of total minus the sum of squares of dosage. Then we get the degrees of freedom, with each is for dosage 4 minus 1, and S is total 12 minus 1. Then error is total minus dosage. Then we get a new column, which is MS, which this comes from the division of sum of squares divided by degrees of freedom. And for dosage is 666 divided by 3 gives us 222. And for the error, 1138.25 divided by 8 gives us 142.28125. Now we get the FO. This comes from the division of 222 divided by 1.48. Now FO comes from the division of 222 divided by 142. Then we have to compare it with the F from the table, which is which was 4.0661806. So, if FO is bigger than 4.06, that means we have to do not reject the HO. Now, we get the residuals. The residuals come from the division of the data minus the average of the line. That means that for N1 for 20 grams is 24 minus 29.75. That gives us minus 5.75. Then for 20 grams and N2, 28 minus 29.75. That means minus 1.75. And then we have to do that for each of the data. Then we have to order it from smallest to largest. And we do this table from 3, and we put 3 columns. Column number 1, the order from 1 to 12. Then sort residual, the residuals from smallest to largest. Then the probability. This probability comes from the formula of order minus 0.5 divided by the total of orders. That means that for minus 25.25, the probability is 1 minus 0.5 and the result divided by 12. Then for minus 6.75, 2 minus 0.5 divided by 12, and then for all of the data. The last step is to make the normality test. This is usually done in a paper called normality paper test. However, as I did it in Excel for easy to use and to see. This is to order in the Y the probabilities and in the X-axis the data, the residuals. Then then we have to put a square in the above 0 and in the range of 25% and 75%. Then we draw a line that goes through all the possible points within the square. Then that would give us all the points that go through the line. That should be all. Thank you very much.